Hello listeners, this is Professor Ackermann Karimi from Jamia Millia Islamia, and now today I am going to discuss about steering system, which is part of automobile engineering in BTech course. This steering system consists of three important portions: steering column and wheel, number 2 is steering gear, and number 3 is steering linkage. Looking at the definition of steering system, we can think about that steering system converts rotation of steering wheel into a swirling movement of the road wheels in such a way that the steering wheel rim turns a long way to move the road wheels a short way. The system allows a driver to use only light effort or light force to steer a heavy vehicle. So, in other words, if I can repeat, the steering system is something which can give vehicle ability to turn towards the right hand side or towards the left hand side. So if we want to go straight, there is no steering. But if we want to go right or left, then we have to use the steering wheel and rotate it. And this amount of force that the driver puts is not as much as compared to the amount of force which is required to turn the whole of the vehicle. So the effort applied by the driver on the steering wheel is very small amount of force, that is, it is very light force that it is applied, and the vehicle, even if it is heavy, it starts turning at the will of the driver towards the right or towards the left. So there is a movement of the steering wheel that the driver has to do, and then steering wheel movement is larger compared to the amount of movement that the front wheel has to turn to the right or left. So if you turn number of times, say one circle of the steering wheel, which is a very big turn, then the wheel of the vehicle wheels will not take one 360-degree turn. It will take a small amount of turn. So this variation of the amount of movement that we give to the steering wheel, but on that movement a small amount of movement of the wheel of the road takes place. There are certain objectives of steering system. So the objectives of the steering system is that, number 1, it helps in swinging the wheels to the left or the right. So the vehicle can be allowed to move towards the right or the left. First objective is to give the ability of the vehicle for the vehicle to move right or left, not just going straight. Number 2, it helps in turning the vehicle at the will of the driver. So if we feel like turning, then only and how much amount of turn that the driver needs, it is totally up to the will of the driver that the wheel will turn as per the requirement. Number 3, it provides directional stability. So if we are going straight, the vehicle should be stably going towards in the straight direction. If we want to turn to the right slightly, then slight amount of turn as per the will of the driver should be maintained, and when it is moving at that particular angle, then it should be stable. It should not get disturbed. So directional stability, the amount of directional change that the driver wills will be maintained in a stable form. Number 4, generally there can be wear and tear of the tires if there is turning taking. If there is going straight, then the amount of wear and tear can be minimum. but amount of wear and tear can increase if we not properly design the steering system. So it controls the wear and tear of the tires if we properly design the steering system. Number 5. Supposing if we are turning to the right hand side and we have already used the steering wheel and turned to the right hand side and moving. But if we now want to go straight, we don't have to put effort on the steering wheel that it should come back to its original position. Even if we leave the steering wheel will come back to its original position of going straight. So by its own, if the turning vehicle steering wheel is left, then the steering wheel turns back to its original normal position of movement in the straight direction. This ability is because of the steering system design and is known as self-rightening effect. Means it becomes straight, it becomes back to its normal position. Even if we are going right or left, if we leave the steering vehicle, then it will come back to its normal straight going position. Number 6. The amount of effort applied by the driver is multiplied depending upon the amount of effort which could have been actually required. So force requirement by the driver is minimized. So there is a leverage because of the steering system. And when there is movement of the vehicle, there are certain amount of shocks which are developed because of the road, because of the situation. That shock coming to the driver is also absorbed by the steering system. So these are the 7 objectives. As easy thing which you can very easily understand. This is a vehicle having first, second wheel, which are the front wheel, and these are the rear wheels. So the line which is connecting the 2 front wheels and the line which is connecting the 2 rear wheels is sitting to have a connection linkage which is known as axle. So this is rear axle and this is front axle. So this is the fixed link between the front wheels, which is the front axle, and this is the rear axle. Apart from the axle, there are other linkages which are there on the front wheel, and these linkages are like this, and there is a rod like here, and then from the road level, the level of the rod which goes to the place where the driver is sitting is known as steering column, and this circular thing that you see is nothing but steering wheel. So the driver has to rotate the steering wheel in order to get movement of this rod, and therefore this wheel, the front 2 wheels, can rotate to give the vehicle turn. So this front wheel is only participating in turning of the vehicle, whereas the rear wheel is not participating in the turning of the vehicle. So this front wheels are part of the steering system, the rear wheel is not part of the steering system, and these 2 wheels, when the vehicle turns because of the front 2 wheels, these 2 wheels are just parallel, they always remain parallel, and they just follow the front wheel. So they are not part of the steering system, which is to be clearly understood. So when we rotate the steering wheel, the front wheel turns, the wheel is missing here, the front wheel turns, and at the will of the driver the vehicle can also turn. The rear wheel just follows. There are ways we can make linkages to achieve movement of the wheels to take left or right turn. So if we want to have this arrangement, there are certain arrangements which can be done in order to achieve the steering. So there are 3 type of systems which I am discussing here today. Is A, 4-bar mechanism, B, Ackermann's principle is a mechanism, and C, Davis mechanism. So let us start with 4-bar mechanism. What is a 4-bar mechanism? Is that there is, this is the wheel in actual position, which is shown by the black wheel which we have seen here, and it is going straight. You see, it is going straight. So the vehicle, when it is going straight, we will have there is a linkage like this which is L-shaped. There is a linkage like this which is L-shaped. It is known as A, and this is known as B. And there is a linkage between this point where the wheel can turn. So you see, this position is fixed. This is axle, and this is a rod which is connected to the axle, and this blue you see the blue A. Don't talk about red position. Let us talk about this. So when it is straight, the vehicle front wheels are like this. A and B are right angle 90 degrees, and they are connected with the green rod. So the fixed rod, which is the axle, and the green rod is known as tie rod. So D is the tie rod, C is the fixed link, A and B are 90-degree type linkages which are connected to the wheel. So if we turn D, position of A will turn. So it is like a L shape which is hinged over here. So this is the hinge position, and this is the hinge position. The hinge position will make it turn. You see now that the tie rod turns towards this. So the tie rod goes to a new position. Tie rod goes to the new position, and then what will happen is that the tie rod goes to this new position. So you see the tie rod has gone from the green position to this new position, which is parallel, and then what will happen is the blue link will become a red link, and the wheel will turn from being straight like this. It will become slant towards this. It will become slant towards this, and therefore the vehicle will now move towards the right. What is important to understand, that if we turn the tie rod towards the left, the vehicle will move towards the right. If they move the tie rod towards the right, then the vehicle will move towards the left, because if we turn the tie rod towards the left, this 90-degree angle link will turn the wheel this way, and we see then it is going to the right, and this left movement giving the right movement of the vehicle. Similarly, if we can change the left movement to the right of the tie rod, then what will happen is the vehicle will towards, if it is right movement of the tie rod, the vehicle will move towards the left. So tie rod movement gives the turning of the vehicle which we want by steering. So this is a 4-bar mechanism where the size of the fixed link and the size of the tie rod is same, and the angle of this particular position is at 90 degrees. This B and A both are 90 degrees type of linkage, and there is difficulty because then it is found that there is something called slip angle which is same for this. Okay, so if we talk about 4-bar mechanism, then we have to understand slip angle. What is slip angle? Is that there is a line which is drawn parallel to the front wheel and the back wheel. So if you see this line which is from front wheel to the right wheel, there is a line which can be drawn from here to here. This line will be a parallel line and it will be perpendicular to the axle. So if we draw a line which is parallel to the front wheel and perpendicular to the axle of the front wheel, then this particular line will be in line to the wheels. The wheels will be like this and will be like this when they are straight. So the wheel will be parallel to this line. The wheel will be parallel to this line. This wheel will be parallel to this particular line. But once the vehicle has to turn, Supposing in this case if it is turning to the right hand side, this means the tie rod here has been moved to the right. So if it is moving towards the right, the tie rod, then what will happen is the wheel will turn towards the left hand side. So left hand side movement of the vehicle shall take place. And when it is turned in 4-bar mechanism, what will happen is the left vehicle and the the left wheel and the right wheel of the front wheels will have angles theta and angle here theta. These two angles of the left wheel and the right wheel will be same. So this angle which is drawn between the angle of the wheels and the line which is coming parallel from front to left points of the axles, then this angle theta and angle theta will be same for the left wheel as well as the right wheel, even when the vehicle is turning to the left or towards the right. This theta may vary. Okay, so this theta will be smaller when the vehicle has turned slightly, becomes larger as it turns more and more. The amount of steering movement, if it is higher, the theta can grow and increasing. But the remarkably important thing which will happen is that the theta value of the left side or the right hand side will remain same. This angle is known as slip angle, and the slip angle in the case of 4-bar mechanism is same, and it should not be same because the vehicle left, when it is turning towards the left hand side, this wheel and this wheel will be having different type of RPM. This wheel will have a lesser amount of RPM, and this wheel should have larger amount of RPM while the vehicle is moving at a certain RPM. So what will happen is this wheel, when it is turning and this is turning larger, so larger amount of turn here, lesser amount of turn here, and vehicle is moving, this wheel will be having a lot of slip. In order to go ahead with this wheel, because the vehicle is moving with the two wheels together. The front wheel I am talking about, the one which is participating in the steering system. Let us look at it at this way. This is rolling condition. So if we have a vehicle, here I am showing on the right hand side movement of the vehicle. So if we have a circle in which the vehicle has to move, and the vehicle is moving this way, so we will say A and B are the front wheels, D and C are the rear wheels. So when the vehicle is moving in the circle, this wheel, front wheel, which is nearer to the center of this circular movement, and B will have to have a lesser RPM, because the number of turn it will take, should be lesser, and the number of turns that A should take should be larger. So this particular wheel should have a slip, should experience slip, and therefore if A and B are at steering different RPM, C and D will also turn, but they are not steering. This is steering, but C and D are not steering. Here also C will be at a lesser RPM and D will be at a larger RPM. But this wheel is participating, a front wheel is participating in the steering, whereas the rear wheel is not participating in the steering. So slip angles of A and B, which are steering wheels, are shown here. The A and B both will be having the same slip angle, whereas the slip angles for proper rolling, the A and B should have different slip angles. So therefore, the disadvantage of 4-bar mechanism is this, that it does not have different slip angles, and therefore because of this reason there is lot of wear and tear of the wheels, tires, and it is uncomfortable, is not working mechanism. It is just an initial form of thought which we had in order to find out what are the ways of making a steering system. I hope it is clear. Now let us go to Ackermann steering. Now let us study about Ackermann's steering system, which is the second system apart from after 4-bar mechanism. So 4-bar mechanism, we had fixed link, we had a tie rod, and we had links which were here, the one which is connecting to the point of the tie rod here and having a hinge point here. This is the point at which this particular shape can turn like this. Similarly, this is the hinge point, and this particular shape 3 can turn like this. So if we put on the wheel here, if we put a wheel, or we have a linkage like this, and we put a wheel here, and if we turn this particular linkage at this particular position, then what will happen? Turn like this, then the wheel will also turn here, and here it will go ahead in this circle. So this particular linkage is the one which is giving you turn of the vehicle as it is pushed by this tie rod here. So you see the tie rod here, it is having particular position here. So this is mechanism at which it is point over here, and this is the hinge point number 1, and this is the hinge point number 2 with the axle. So this is the axle. So the fixed axle is connected to the 2 hinge points of connection 2 and 3, and fixed rod is connected 2 and 3, and fourth rod, which is tie rod, is connected to the 2 and 3 at this position with 2 and this position with 3. The fourth rod, which is the tie rod, which can slide to the left or to the right, turning the 3 and 2 linkages at this fulcrum position. So we have length of the tie rod. In case of Ackermann principle, his steering system is not equal to the fixed length of the axle. So the fixed linkage is larger and tie rod is smaller in case of a Ackermann steering system. But in case of 4-bar mechanism, it was same. You see, 4-bar mechanism, the length of the tie rod and the length of the fixed link was same, and that is why the angle of B and A was 90 degree. I have changed the name. So here we see the angle is no more 90 degree, it becomes alpha, which is larger than 90 degree, and this is also larger than 90 degree for the link 2 and 3, because the tie rod is now smaller in size. So this is the difference between the 4-bar mechanism and Ackermann principle. So the angle alpha is more larger than 90 degree as compared to the 4-bar mechanism. And how do we exactly select the size of tie rod? Is by looking at the vehicle. So if we have the front wheels with this axle 1 and the rear wheels, and we draw a line of the axle and draw the line of the axle. So if we draw from point A, which is the hinge point, and C, which is the hinge point for the connection 3 and 2, so we can draw a line which is exactly at the center, which is E of the rear axle. So if we take the point E of the rear axle and take XX equal length on the rear axle, so this is the rear wheel, which is not participating in steering system. But if we just take a point E here and join C to E and A to E, then we will get the point B and D, and therefore the length of the tie rod can be fixed as BD depending upon the length of distance between the rear wheel and the front wheel. Larger is the distance, shorter is the distance, then it can make difference on the length of the position of the tie rod BD. So BD is the tie rod, and B and D can be known with the help of joining it to E, which is the center of the rear axle. So if this is the situation, the front wheel, which is W1 and W2, will be having linkages known as Ackermann principle. So Ackermann principle is what? This angle alpha is chosen such that if AB and CD are extended, if AB and CD are extended, they meet at point E, which lies at the rear wheel axis line at center. So this is the method in finding out, and such system will have different angles of slip angles of W1 and W2. So if we will have this system, then the slip angles of wheel number 1, which is the left side, and the wheel number 2, which is the right hand side, in this case, the slip angles will vary because the distance has now become, tie rod length has now become. I tried to draw this figure, but this figure is not correct, so please don't go ahead with that. Let me see it and try it at this particular figure which I have drawn. This particular video which I am making is amalgamation, or has been inspired by videos available in the YouTube as well as books that I have seen, and some of the definitions which were there on Google, which I have tried to compile it here in order to understand easily with our subject of steering system. So let us look at it. C is the center, and 2 and 3 are the distance of the tie rod. 2, 3 is the tie rod, and this is the point of the hinge. This is the point of the hinge. So we see 1 going to the point of the hinge and 2. Okay, similarly 4, which is a dotted line, going to the point of hinge and coming to 2. So this is link 2.4, and this, sorry, 3.4, and this is 2.1. This linkage and this linkage is connected to 2, 3, which is the tie rod, and we have from here to here. I should name it. I think I should name the 2 points, which is here. Why am I just saying points? This is say A, and this is say B. So 1B2 is the linkage, and 4A3 is the linkage, which is connected to the tires and the tie rod. So point number 3 and 2 is, this distance is known as the tie rod, which is coming at the center of the rear axle line at C. So this is Ackermann principle. But now if we supposing, and this angle is 90 degrees, this angle is 90 degrees, but this angle is not 90 degrees, you see. So this angle is more than 90 degree, and this angle is here, is 90 degree. Now supposing the vehicle has to turn to the right hand side, as in this case. If it is turning to the right hand side, then what will happen is the tie rod will have to move to the left hand side. The tie rod moves left hand side, then what will happen is position of the tie rod will change. See, so 3 shifts to point number 3 dash, and similarly 2 shifts to the point of 2 dash here. So the overall movement of the tie rod is taking, but you see 2 is not very larger towards this and 3 is larger towards that, and the vehicle now when it is turning, so what will happen is that if we see now 3A4 has come 3-A4 dash. Similarly, if from 2 to 2 dash the tie rod has traveled, then we will see that as it was earlier 2B1, now it has become 2-B1 dash, and that is why this wheel, left front wheel and right front wheel, has turned. But the important thing of turning is that if we draw a line from the wheels and try to just extend it, and draw a line from the wheels and just trying to extend it, which is perpendicular to the wheels, then whatever these 2 points will come to a point over here and merge at a point which is lying on the rear wheel line extended over here. This particular point will be same, and that particular point is known as instantaneous center. So what is instantaneous center? It is a center which is lying on the rear wheel line, and also it is a point which is coinciding with the left wheel and right wheel of the front front steering system, and it is having a point common. And the angle of the left wheel, angle of the right wheel will be different. You see, this is the slip angle. This is the same slip angle. So if you see this, the angle which the line and the wheel makes, this particular line and the wheel which turn has made. So this angle and this angle will be different. You see, this is alpha and this is beta. So alpha is this, seems to be this is alpha, and it will be on this particular wheel, and this is beta which is on this particular wheel. So the slip angles of the two wheels are different, and therefore the RPM of the inner wheel will be lesser and RPM of the outer wheel will be larger. This is adjusted because of the changes that we have made from 4-bar mechanism to Ackermann's principle, and this is how it accommodates in order to minimize the wear and tear of the wheel and gives you stability of the wheel. And it also works that when you leave the wheel, it will create a force where this turned wheel will automatically become straight if you leave the steering wheel. That force analysis has to be understood with the help of moment analysis. So I read it out for you. Steering wheels WF1, front wheels WF1. So WF1 is this and WF2 is this. WF1 and F2 steering front wheels. These wheels are having different RPMs. That is, this is larger RPM and this is lesser RPM. And rear wheels also have a larger RPM and lesser RPM, but they are not having inclination. They are just following. You see, it is not affected by the steering. And I is the instantaneous center, and IR is the standard. And I, if we are turning toward the right hand side, then I, which is I right hand side instantaneous center, will be having a position. The amount of turn that we will take the wheel, this instantaneous center will be here, and it can shift up to here and it can go up to here. Like, it will vary from position to position depending upon the steering amount that you have taken with the wheel, amount of turn that you have taken. It is not a fixed position. So I instantaneous center is not, it is instantaneous to the point the amount of turn that you have taken, it is at that particular moment the center which is at that instant. So the instant you change the steering wheel angle, this center will also shift. So if you are turning to the right hand side, the instantaneous center will be on the right hand side. Similarly, if you are turning to the left hand side, the instantaneous center will shift towards the left hand side. So I will read out for you. IR will be on the right turn and IL will be on the left hand side. The slip angle alpha and beta at every situation will remain different. X alpha and beta will at every situation, wherever is the I position, alpha and beta will be different. The value of alpha and beta will go on being different, and therefore the amount of RPM of inner wheel and outer wheel will go on changing depending upon the amount of turn that a person has taken. It is up to the will. So the slip angle alpha and beta at every situation will remain different except when the wheel is unsteered or is parallel. So agar hum log bilkul, if we are straight, then there will be no slipping. The two wheels will be having same RPM. When we are not turning, the two wheels are with the same RPM, and therefore the slipping at that moment is not so significant as when we are turning. So that slipping is being covered up, it is being taken care of if we are applying Ackermann's principle, which is generally available in all vehicles which we use. Thank you.